projectile motion is what this project is about. And you just have to click through it. So we decided to discuss what is projectile motion first. Projectile motion refers to the motion of an object projected into the air. It can be seen in most sports that students play, such as baseball, football, a soccer ball being kicked, or even an ice skater where they're jumping. It's feeling better now. Didn't want to speak first. It can also be seen in things that people know of, like fireworks, waterfalls, and even cannons launching. This project approaches the physics core standards in New York State, Standard 1, and as well as Standard 4 and 5. You just go through them because people don't want to read the standards. Okay, this is how our demonstration begins. The cart is at the top with the servo motor holding it in. When it's at the top of the platform, it goes down, and it actually needs two things to be set. One, it needs the servo motor to be set here so that the cart can be behind it, and it also needs for this ball to be at the launch, and for the solenoid on top to be depressed backwards so it can shoot. Okay? Then you're ready to begin the demonstration, which we had started before. And the P-Basic program downloads the program. As you heard, it says hello and welcomes the user. The servo motor resets itself and then lets go. And on the debug window that's over there, it asks you what angle would you like to input. Okay, when it's coming down, I'll let Bill talk about the potentiometer for a second.
Okay. Anyway, what the device does is you enter an initial angle to it. We've got a motor and a drive screw back here, which operates painfully slowly, which is one of the reasons we didn't change this initial angle on it. We decided to keep it basically at the same angle that it was before we got started. Now, over here we have a potentiometer which is connected to the analog digital converter, which gives us basically a digital code relative to what the angle of this incline is. So it'll go through a cycle, continue to cycle through until it gets to the point where it decides that, okay, we are at the correct angle. Then it stops. You get a countdown from the sound card. I think we're going to try it one more time. Going to try it? Okay. It gives you a countdown from the sound card. The card comes through here and passes through these two photogate timers. And the photogates, when it passes through the initial one, it starts cycling through an iteration, a do loop basically. It continues to count up, 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 and then ends when it passes through the second timer. Now, when it passed through that second timer, the do loop stops. We know the time for each iteration, and it's able to determine the speed of the cart as it's going through those two photogates. After it passes through the two photogates, it comes down to the end here. There's another iteration that comes through. It begins calculating on that second iteration, and the piston, supposed to, push forward, and the ball lands in the cart. Ran probably about 20 times fine over the last 2 days. And I'm just trying to figure out why it's decided that it didn't want to work at this point. The last part of the experiment, or of the demonstration, is the sound card is able to produce what the actual velocity of the cart passed through the photogates at. No luck? Okay. Anyway, what we were hoping to use this for is it's a nice demonstration to get the kids interested in both projectile motion and conservation of energy. If you wanted to, we can ask the kids to determine the height that the card has fallen, calculate out what the speed should be, have it verified by the device as it goes through the two photo gates. It also gives them an idea of projectile motion. You've got a horizontally fired projectile here. The time, of course, is based upon the height that it has to fall down into the cart, and that is consistent. And there's a time delay that has to be calculated from when the cart passes through the photo gates until when it actually fires.